Hello students, welcome to this video. Today in this video we shall discuss on integration by partial fraction. This type of integration comes in the form of f of x to the power n by f of x to the power m, where m is greater than n and both m and n are natural numbers, and this f is polynomial function of x. And most importantly, the degree in the numerator is obviously less than the degree in the denominator. So before I go for details, I must tell you that there are three categories. Category number one is the denominator has different linear factors. For this case, we have to take this total function is equal to a by x minus alpha and b by x minus beta, because x minus alpha and x minus beta are the linear factors, and we will forget about this f of x to the power n, I mean the numerator part. And in this case, let us assume that this numerator has degree less than the denominator. In the next category, let us take the denominator as x minus alpha into x minus beta whole square. Here you can see that x minus alpha is non-repeating factor and x minus beta is repeating factor. For this case, because x minus alpha is non-repeating factor, okay, so from the first category, we can take this total function as a by x minus alpha, and because see here is no non-repeating factor, so we have to go for another rule, that is if it is a repeating factor, then we have to take b by the repeating factor, that means x minus beta whole square. And because x minus beta is a factor, so that is why we have to take another constant c, and it will be c by x minus beta. Now see that here the degree of the denominator was 2, so we had to take two constants a and b. Now here the degree of the denominator is 3, so we have taken three constants a, b and c. So let us go for the third category. In the third category, the denominator has x minus alpha into x square plus px plus q. Now see that here x minus alpha is a linear factor, but this x square plus px plus q, suppose we are not getting any middle term factor for this quadratic function. For this case, what you have to do, because this is a non-repeating factor, so as usual we have to take a by x minus alpha. Now for this quadratic equation, we have to take in the numerator bx plus c and in the denominator x square plus px plus q. Now if you go for the degree of the denominator, here the degree of the denominator is 3. Now we have taken three constants in the numerator a, b and c. Now this is the combination of the three forms. Here the denominator has the non-repeating factor x minus alpha, the repeating factor x minus beta whole square, and the quadratic function x square plus px plus q. Now the blue one, which is non-repeating factor, for this case we will take a by x minus alpha. For the red one, we will take b by x minus beta whole square plus c by x minus beta, and the black one, for this case we will take dx plus c divided by x square plus px plus q. Now if you count the degree, see 1, 2, 3, 4, 5, and let us see how many constants are here. A, B, C, D, E, 5 constants, and that is how we have to proceed. Now the question is, after that, what to do? So let us go for some examples to describe the process properly. Here the question is integration of x plus 1 by x plus 2 into 3x plus 1. Here the denominator has two linear factors. So before we go for the solution, let us observe the nature of this function. The first thing is the degree of the numerator is equal to 1 and the degree of the denominator is equal to 2. So definitely it is less than this one. Now the next thing is the denominator has different linear factors. Those are x plus 2 and 3x plus 1. So for this case, the total function will be equal to a by x plus 2 plus b by 3x plus 1. Now we can write x plus 1 is equal to a into this denominator divided by x plus 2 and b into this denominator by 3x plus 1. So after this cross multiplication, we can cancel out this x plus 2 and this 3x plus 1 from both the numerator and the denominator, and here we get x plus 1 is equal to a into 3x plus 1 plus b into x plus 2. Now this equation is true for any real value of x, so that is why we can assume any value of x to find the value of a and b. So if we take x is equal to minus 2, so from this equation we get minus 2 plus 1 is equal to a into minus 6 plus 1 plus b into 0. So this gives us a is equal to 1 by 5. Now let us take x is equal to minus 1 by 3. So if we take x is equal to minus 1 by 3, so this equation becomes minus 1 by 3 plus 1 is equal to a into 0 plus b into minus 1 by 3 plus 2. And this gives us b is equal to 2 by 5. Now we shall put these two values in this equation. Now these values of a and b have been put in this equation, and we have got this x plus 1 by x plus 2 into 3x plus 1 is equal to 1 by 5 into 2x plus 2 and 2 by 5 into 3x plus 1. Now if we put the integration sign in the left hand side, so this integration sign will be put on both the terms in the right hand side. Because this is in the form of dx by x format, so that is why we will get logarithmic function for both the cases, and in this case because 3 is the coefficient of x, so that is why it will be multiplied with the denominator. And so this is the final answer for this integration. Let us go for the next category. That is, the denominator has a repeating term and a non-repeating term. So let us observe the nature of this function first. Here the degree of the numerator is equal to 1, which is less than the degree of the denominator, that is 3. And next is the denominator has two different terms, that is x plus 2 and 2x minus 1. But one of them is repeating, that means this x plus 2 is repeating factor. So we will write this whole function in this way, that is a by x plus 2 whole square, b by x plus 2 and c by 2x minus 1. Now see, x plus 2 is the repeating factor, so that is why it will appear twice, and because 2x minus 1 is non-repeating factor, so it is appeared once. Now see, the degree of the denominator is 3 because of square term and the linear term, so that is why we have got 3 constants in the right side. Now if we go for cross multiplication, then after this cancellation process we will get a into 2x minus 1, b into x plus 2 into 2x minus 1 and c into x plus 2 whole square. Now this equation is true for all real values of x. So if we assume that x is equal to minus 2, so this equation becomes minus 2 into 1 is equal to a into minus 4 minus 1, b into 0 and c into 0. Because if you put x equals to minus 2, it will be 0, and if you put x equal to minus 2 here, it will be 0 also. So this gives us a is equal to 1 by 5. If you put x is equal to half, so this equation becomes half plus 1 is equal to a into 0 plus b into 0 plus c into half plus 2 whole square. Because if you put half over here, so this term will become 0, and similarly this will become 0. So this equation gives us c is equal to 6 by 25. So we have got a is equal to 1 by 5, c is equal to 6 by 25. So let us put x equal to 0 in this equation, because this equation is true for all real values of x. So we have put the values of a, b and our assumed value of x in this equation, and we have got this one. So this gives us b is equal to minus 3 by 25. Now we shall put the values of a, b and c in this equation, and after that we will proceed for the integration. So after putting the values of a, b and c, we have got this equation. Now if you put integration sign in the left hand side, so this sign will be put for all the terms in the right hand side. So this integration will give us this result. You can pause the video and verify this answer with your answer also. So for this integration, we have got one non-repeating factor and one quadratic factor in the denominator. Because this quadratic factor is not factorizable, that means you cannot find any middle term factor for this quadratic function. So we have to follow the category 3 process. Now if any quadratic function is there in the denominator and you can find the middle term factors for that quadratic function, so obviously we will be directed to the category 1 and category 2 process. So let's see what will be the solution of this one. Now see here, this is non-repeating factor, so that is why we will write a by x minus 1, and this is the quadratic factor, so that is why for this quadratic factor we will write bx plus c by x square minus x plus 1. Now see, this has degree 3, this denominator has degree 3, so that is why we have got 3 constants in the right side. Now after cross multiplication we have got this result, and this equation is true for all real values of x. So let us take x is equal to 1 and put the value of x in this equation, and this equation becomes this one. So this gives us a is equal to 1. Because we can put any value of x, so that is why in this equation we have put x equal to 0 and it has become this one. Now you notice one thing, because we are going to find the values of b and c, so that is why we can put the value of a over here. So this gives us c is equal to 1. We have got a is equal to 1, c is equal to 1. So let us take x is equal to minus 1, because we can put any value of x over here. Now we are putting all these values in this equation, and let's see what comes. After putting these 3 values over here, we have got this equation, and from this equation we will get the value of b. So this gives us b is equal to minus 1. Now our job is to put these values of a, b and c in this equation. So after putting the values of a, b and c, we have got this equation. So if you put the integration sign in the left hand side, it will be put in the right hand side for each term. So here I have solved the integration. Though there are some step jumps, you can pause the video and see the process followed. Thank you so much. I hope you have understood. So thank you for watching the video.